Good morning to one and all. Today let us see the basic circuit laws. Before going to the circuit laws, let us see what are the objectives of this lecture. We are going to state, state and explain the relationship between the resistance, current and voltage, which is Ohm's law. And we will discuss about the Kirchhoff's current law and Kirchhoff's voltage law with a small and sample purpose. We'll see these Kirchhoff's laws. Firstly, resistivity. Resistivity is a material property dependent on the number of free or mobile charges in the material. Before going to see the Ohm's law, we will see about the resistivity and then the resistance. So, in a material, in a material, like take or it may be a metal or a semiconductor material. In this is a number of electrons from outer shell that are ionized and become part of the sea of electrons, dependent on the mobility of charges. Mobility is related to the velocity of charges. It is the function of material, the frequency and the magnitude of voltage applied to make the charges move and the temperature. So, resistivity is a property of a material. So these are the some common materials at room temperature which are going to have the resistivity. For silver it is 1.64 10 to the power minus 8, and it is used as a conductor. Copper it is 1.7 10 to the power minus 8 and is also used as a same conductor. Whereas germanium silicon we are going to have the resistivity at 0.47, which are used as a semiconductor, and the silicon for 640 it is also semiconductor. An insulator is paper is insulator, which is going to have resistivity of 10 to the power of 10, which is insulator. It is a not conductor of electricity. Similar, we are going to have the other insulator materials, mica, paper, glass, and Teflon. So this is resistance takes into account the physical dimension of the material. R is capital R, resistance R is equal to rho into capital L by A, where capital L is the length of along which the current is going to or moving, and capital A is a cross-sectional area of the free charges move through this area, and this is the length. So resistance is the property of a material to oppose the flow of currents. In simple manner, we can say like that. And let us go to the Ohm's law. This is the main part of our lecture. The Ohm's law. In Ohm's law, the voltage drop across the resistor is proportional to the current flowing through the resistor, which is given by V is directly proportional to current. So we are going to eliminate this proportionality by using a resistance capital. V is equal to I into R here. This is the Ohm's law. Coming to the Kirchhoff's current law. In general, we can say the statement of the Kirchhoff's current law as the sum of currents entering a node equals the sum of currents leaving that particular node. Or exiting at that particular node. So if you see a simple branch node here, this is a node which is a combination of two or more branches here. At this particular node, there is a there is a the change in the direction. There is splitting of the current at this particular node. So let us see a simple example here. This is a node where a current of 2 amperes and 3 amperes I1 and I2 are going to enter at this particular node. So and then the current at this junction leaving is nothing but I3 is equal to 5 amps. Nothing but at this junction, if I am going to add all these currents, the sum of currents entering at this particular node, so 2 plus 3 is nothing but 5 amps is equal to the current living at that particular node, which is nothing but 5 amps. Or I can say 5 amps and the I3 is in the opposite direction to that of from the junction or this node. So we can take this current I1 plus I2 minus I3 is equal to 0. The sum of currents at this particular node is equal to 0, or the current entering at this particular node is equal to the current leaving at that particular node. Nextly, we'll see another example here. If the currents are entering at this particular node or junction are I1, I2 and I3, that is I2 plus I3, I2 plus I1 is equal to I3. So I1 plus I2 is equal to I3. We doesn't know about I2, but we know we doesn't know about I1, but we know about I2. I1 plus I2 is equal to I3. So I1 is equal to I3 minus I2. 250 minus 150, nothing but 100 milliamps. So I1 is equal to 100 milliamps. So 100 I1 100 milliamps plus I2 150 milliamps is nothing but I3 250 milliamps. This is a simple problem which gives an idea about the KCL, Kirchhoff's current law. Nextly, we'll see about the Kirchhoff's voltage law. The statement of this Kirchhoff's voltage law is the sum of the potential difference around a closed loop is equal to zero, or the sum of voltage drops in a closed loop is equal to zero. So let us consider this as a simple closed loop here or a network. So in this closed loop, we are going to have there are four loops here. This is 1, 2, 3, and 4. And next one, the total is 5. This is the fifth loop here. So a loop is nothing but a closed path here. This is one loop, and this is another loop, and this is another loop, and this is another loop. So in this I have mentioned the loop is from here to this is another loop. So the voltage drops in this closed loop is equal to zero according to the Kirchhoff's voltage law. So what the really it means to say the Kirchhoff's voltage law is the sum of voltage drops across the resistors equals to the supply voltage in that loop. If there is any voltage source in that loop, then it is equal to the sum of voltage drops of the resistors is equal to the supply voltage or the voltage source in that loop. So let us see, this is a simple example here which gives the idea about the Kirchhoff's voltage law. So it consists of three resistors. This is the voltage, supply voltage. So the current through the resistor R1, let it be R1 here, and this is R2, and this is R3. So the current through the R1 is I is equal to 2 amps, and current through the R2 is I is equal to 2 amps, and R3 is equal to 2 amps. As these three resistors are connected in series, so the current flowing through all these resistors is 2 amps only. Similar, and the resistance of the first resistance is R is equal to 3 ohms, and R is equal to 4 ohms, and R is equal to 5 ohms here. So this resistance is nothing but 3, and this is 4, and this is 5. So this voltage, the source voltage, is nothing but the voltage drop across this closed loop. So if I am going to multiply V is equal to, from the Ohm's law we have V is equal to I into R. So 2 into 3, 6. V is equal to 6 volts. Here 8, and then here 5, 2 into 5, nothing but 10. So 6 plus 8, 14, 14 plus 10, 24. So the total voltage source, uh, supply voltage source here is 24 volts, which is applied through this closed loop. So these are the advantages of the Kirchhoff's voltage law, Kirchhoff's current law, and Ohm's law. So let us have the summary of this total lecture here. So resistivity is the fundamental material property, while the material properties and the geometry of the component determine its resistance. Ohm's law. The force required to have a specific current flow through a resistor is given by V is equal to I into R. Or the voltage across the resistance is proportional to the current, so which is given by V is directly proportional to I. By removing that relay directly proportional to, we have V is equal to I into R. The sum of currents entering a node equals to the sum of currents existing a node. The sum of voltage drop across the resistance is equal to the sum supply voltage in that loop. This is Kirchhoff's voltage law, and this sum of currents entering a node is equal to sum of currents existing or leaving that particular node or junction is nothing but Kirchhoff's current law. So these are the basic laws of the basic electrical circuit laws. Thank you. for giving this opportunity.